During the past few years, a new and unexpected cause of foodborne illness has been in the news: sprouts. Sprouts have recently been recognized as the cause of outbreaks of foodborne illness here in the United States and in other countries around the world. Hi, I'm John Wallace.
And I'm Jane Queeby. This video is designed to help you realize and understand the dangers of foodborne illnesses and also to provide valuable food safety information on seed production and processing that will help eliminate the spread of disease and avoid harming the public.
This video series is broken down into a number of specific modules. In Module 1, we will review food safety and what constitutes a foodborne illness.
Module 2 addresses legal requirements and suggested food safety guidance.
Module 3 addresses all aspects of sprout processing practices, from seed production to the sprouting operation.
Module 4 will address personnel practices and procedures to help ensure that employees follow proper techniques that will reduce the spread of pathogens.
And finally, in Module 5, we will point you to additional materials that will be valuable to you. So what are foodborne illnesses? Foodborne illnesses are those sicknesses that result from eating food that contains harmful microbes called pathogens. These pathogens cause symptoms like diarrhea, vomiting, and stomach cramps. Sometimes fever also occurs. Usually these illnesses do not cause serious health problems, but certain groups such as the very young, the elderly, and the immunocompromised may be more susceptible to serious complications of foodborne illness. These may include severe outcomes such as paralysis, kidney failure, or even death. For each illness that health authorities hear about in a foodborne outbreak, there are many other illnesses that happen in the community that are never reported. This is because illnesses are reported to health authorities by doctors or laboratories. So if a person does not seek medical care, or the doctor does not get a stool sample from the ill person to send to the laboratory, the illness will probably not be reported. For example, in some foodborne outbreaks caused by the pathogen called Salmonella, it's estimated that for each reported case of illness, there are another 37 illnesses that go unreported. This means that even a small outbreak involving 20 reported illnesses may actually mean that several hundred people were ill. Also, many foodborne illnesses occur that are not part of recognized outbreaks. Overall, it is estimated that about 76 million foodborne illnesses occur in the U.S. each year, resulting in thousands of deaths. The economic burden from missed work and productivity is estimated to be in the billions of dollars. Over the past several years, sprouts have become a common fresh produce item linked to foodborne illness, especially Salmonella infections and E. coli 0157H7. A scientific advisory group to the Food and Drug Administration has recognized sprouts as a special problem. This is because bacterial pathogens that may be present on sprout seeds at the time of sprouting can multiply to very high levels during the sprouting process. Since 1995 in the United States, at least 13 outbreaks due to eating seed sprouts have been recognized, resulting in over 1,000 laboratory-confirmed illnesses. It is likely that several thousand other illnesses also occurred, but were not reported. 2 deaths were reported to be associated with these outbreaks. In the United States, some of these outbreaks were quite large and affected people living in many states. 2 types of pathogens, Salmonella and E. coli 0157H7, are important causes of foodborne illness associated with sprouts. In addition to the usual gastrointestinal symptoms, Salmonella infections can sometimes spread to the blood and cause serious or even fatal illness, especially in small children, the elderly, or in persons who do not have normal immune systems. Infection with E. coli 0157H7 causes severe bloody diarrhea and in small children can cause kidney failure. Any type of raw sprout can become contaminated with pathogens and cause illness. Alfalfa sprouts have been the most frequent kind of sprout involved in foodborne outbreaks in the United States. However, other types of sprouts, including clover and radish sprouts, have also been linked to illness. Most sprout outbreaks are due to seed that is contaminated with pathogens before the sprouting process begins. It's not surprising that sprout seed can be contaminated with pathogens. Pathogenic bacteria like Salmonella or E. coli 0157H7 are commonly carried in the intestines and excreted in the feces of many kinds of animals. Sprout seeds are a raw agricultural product that can come into contact with animal feces any time during growing, harvesting, processing, or storage. Bacterial pathogens can be found in animal manure used as fertilizers in fields, or they may contaminate irrigation water. Many pathogens can survive for months under the dry conditions used for seed storage. Although contaminated alfalfa seeds have been identified as the source in many outbreaks, any type of sprout seed may be contaminated with bacterial pathogens. Because alfalfa, clover, or other seeds used for sprouting are not primarily grown for human consumption, the crop's growing, harvesting, storage, or processing conditions may provide many opportunities for contamination. Scientific investigators have been able to recover the same bacteria from ill people and from the same seed lots used to grow the sprouts. Once contaminated seeds are brought into a sprouting facility, this contamination can be transferred to other sprouts and seeds by a process known as cross-contamination. This emphasizes the need to have good manufacturing practices and a careful quality control program for sprout production. Recent outbreaks causing illness and even deaths have created much concern by consumers. The families of some ill persons have initiated lawsuits. Consumer groups have begun to demand a safer sprout product, or to have sprouts carry warning labels advising consumers of the risk of illness from consuming the product. Some groups have even suggested banning the sale of raw sprouts. There have been both negative and positive consequences of this problem for the sprout industry. On the negative side, some sprout facilities which produce sprouts that caused outbreaks have gone out of business. In some areas, product sales may have decreased, and retailers may have less interest in carrying sprouts. On the positive side, the sprout industry has worked with government and academia to fund important research to investigate ways to disinfect sprout seeds and to develop manufacturing guidance. Regulatory agencies have been working with academia and the sprout industry to develop specific guidance for sprout growers. They have also been working with the industry to conduct research into seed disinfection methods and microbial testing. Although there have been commendable efforts by industry and regulatory agencies working together to address sprout safety issues, the problem has not yet gone away. This may be due to several reasons. Recent information on seed disinfection methods may not yet have reached all sprouters, or if it has, it may not have been put into practice. While some sprouters are quite knowledgeable on food safety and sanitation issues, others are less experienced. Regulators may need to consider more stringent measures on sprouts if outbreaks continue to occur. To review, foodborne illnesses are those sicknesses that result from eating food that contains harmful microbes called pathogens. Foodborne disease causes millions of illnesses in the United States each year. Since 1995, in the United States, at least 13 outbreaks due to eating seed sprouts have been recognized, resulting in over 1,000 laboratory-confirmed illnesses and at least 2 deaths. Although 2 types of pathogens, Salmonella and E. coli 0157H7, frequently cause foodborne illness associated with sprouts, other bacterial pathogens may also be important. Alfalfa sprouts have been implicated in most sprout-associated foodborne outbreaks. Other sprouts, including clover and radish sprouts, have also been linked to illness. Most sprout outbreaks are due to seed that is contaminated with a bacterial pathogen before the sprouting process begins. Once contaminated seeds are brought into the sprouting facility, this contamination can be transferred to other sprouts and seeds by a process known as cross-contamination. Sprouts are now recognized as an important cause of foodborne illness that has had an impact on the public, the industry, and upon regulators.
Federal, state, and local agencies all share responsibility for ensuring that food processors follow food safety laws and regulations. The goal of these laws and regulations is to protect the public by ensuring that food processors produce safe food. There are a number of tools available to help sprouters comply with the law and produce safer sprouts. These tools include regulations and government guidance, as well as voluntary programs developed by sprouters themselves. In this module, we will discuss in depth the requirements and guidance for sprouters and clarify and define many of the terms and definitions surrounding existing laws and regulations. At times, the abbreviations for these tools may sound a little like alphabet soup. For clarification, each tool is identified in this table as a law or regulation, a guideline, or a voluntary program. Laws or regulations are the legal requirements that should be followed. Guidelines are government recommendations, often suggesting how the government believes you can best comply with laws and regulations. As the name implies, voluntary programs are completely voluntary. In many cases, voluntary programs developed by food industry or grower associations have served as guidance for their members. While government guidelines and voluntary programs are not mandatory, they should be carefully considered as they are excellent resources for the implementation of food safety programs and sometimes on ways to comply with legal requirements. Local, state, and/or federal government public health agencies may inspect a Sprout facility. Federal regulators have jurisdiction over products that move across state lines, otherwise known as interstate commerce. State regulators may adopt federal requirements in their own state laws. Some states have adopted requirements that should be met in addition to federal requirements. Sprouters should comply with all existing state and federal laws and regulations that apply to food establishments. The first of these is the Federal Food, Drug, and Cosmetic Act, which is sometimes referred to as the FD&C Act or simply the Act. The Act fits into the table under laws and regulations. The Act is the legal authority for food inspection in the United States. The Act was introduced nearly a century ago to protect public health. It also creates a level playing field for the food industry. Sprouts are food. The Act prohibits the sale of adulterated food. In the words of the Act, food is considered adulterated if it contains any poisonous or deleterious substance which may render it injurious to health, Section 402A. If it consists of any filthy, putrid, or decomposed substance or is unfit for food, Section 402A. Or if it has been prepared, packed, or held under insanitary conditions whereby it may have become contaminated with filth or rendered injurious to health, Section 402A. In other words, the sale of adulterated food is illegal. Adulterated food is defined as any food containing a pathogen such as Salmonella, E. coli 0157H7, or any other harmful substance. Foods that are spoiled or that are prepared using spoiled food, or foods that are contaminated with insects, rodents, or other types of filth are considered to be adulterated. High-quality food prepared or stored in a dirty environment or handled by workers with poor personal hygiene is also adulterated, because these conditions greatly increase the likelihood that the food may become contaminated with harmful substances. When food is adulterated, regulators have tools that they use to address the problem. In some cases, they may ask the firm to voluntarily make the appropriate corrections. Sometimes the regulator will send a warning letter to the firm. In other cases, the product may be seized. A seized product cannot be sold unless the court releases it. Finally, in serious cases, the regulators may file an injunction to stop the firm from producing food, or they may prosecute the responsible persons, typically the facility manager or owners. GMPs are also regulations. GMPs are short for Good Manufacturing Practice in manufacturing, packing, or holding human food. These regulations can be found in Part 110 of Title 21 of the Code of Federal Regulations. The GMPs were developed with input from the food industry to ensure that processed food is produced under conditions that meet minimum food safety standards. A copy of the current Good Manufacturing Practices in manufacturing, packing, or holding human food is provided in your materials. A complete copy can be obtained by ordering at 1-202-512-1716 or downloading from the FDA website at www.fda.gov. The GMPs for Food Part 110 are comprised of several subparts, which include general provisions, buildings and facilities, equipment, production and process controls, and defect action levels. Section 110.10 of the GMP describes the requirements for personnel education and training. This section emphasizes the need for adequate employee training in proper food handling and food protection. It includes identifying the dangers of insanitary practices and poor personal cleanliness, and how these practices can lead to consumer and employee illnesses. The responsibility for ensuring adequate training of employees should be assigned to competent supervisory personnel. Supervisors and managers are also responsible for ensuring that employees adhere to all of the requirements of good manufacturing practices. Facility construction and design are discussed in the Plant and Grounds section 110.20. Included in this section are specific requirements for facility layout that provide adequate separation of raw materials from finished product. This section identifies methods to avoid cross-contamination of food and its contact surfaces or packaging material. General maintenance and pest controls are discussed in the Sanitary Operations section 110.35. This section outlines proper sanitation of food contact surfaces and storage of cleaning materials, cleaned equipment, and utensils. The Sanitary Facilities and Controls section 110.37 addresses water supply, plumbing, sewage disposal, toilet facilities, hand washing facilities, and rubbish disposal. The Equipment and Utensils section 110.40 states that all equipment should be designed and constructed so it is durable and easily cleanable. Food contact surfaces should be smooth, non-porous, non-toxic, and should not contribute off odors or colors. Corrosion-resistant materials should be used in construction because rust is difficult to clean and allows for growth of microorganisms. Seams should be smooth and free of cracks or crevices. All equipment should be properly cleaned and maintained. Examples of acceptable equipment materials include some types of stainless steel, various plastics, and laminates. Some types of stainless steel can corrode. Stainless steel that can corrode is not acceptable for sprout production. It is very important that equipment and utensils be constructed of food-grade materials. Not all items found in general hardware stores or variety stores are recognized food-grade materials. If uncertain, contact the NSF International to verify whether or not a material is considered food grade. Utensils used in food production should meet the same criteria used for equipment. All equipment and utensils should be cleaned and sanitized daily or more frequently as needed to avoid product contamination. Information on cleaning and sanitation techniques for food contact surfaces, equipment, and utensils is provided later in this video. Cold storage compartments play an important role in keeping many types of foods safe, but are also potential sources of contamination. All refrigerators used to store or hold food should be fitted with a thermometer that accurately indicates the temperature within the compartment. This indicator should have an automatic control for regulating temperature within the compartment or an alarm system to alert of equipment failure. Cold storage compartments should be of sufficient size to allow storage of food so that there is sufficient airflow for cooling, protection of the food from seepage, foodborne filth, and overhead condensation from fixtures, ducts, and pipes. Processes and Controls section 110.80 covers all operations in a food processing facility from receiving through preparation, packaging, and storage of food. This section stipulates that all operations in the receiving, inspecting, transporting, segregating, preparing, manufacturing, packaging, and storing of food should be conducted in accordance with adequate sanitation principles. The company should use appropriate quality controls to ensure that the food packaging materials they use are both suitable and safe, and that the food is suitable for human consumption. This is only a brief outline of the good manufacturing practices that are required for processed food. Although some food, such as raw agricultural commodities, are currently exempt from GMPs, GMPs can be useful in helping sprouters control their process during all stages of sprout production. In addition, some states, including California, have incorporated the GMP regulations into the state health and safety codes, making them requirements for all foods produced in the state. Once a facility has implemented GMPs, other tools can be considered to enhance operations and to supplement a food safety program. For example, Standard Operating Procedures, or SOPs, and Sanitary Standard Operating Procedures, or SSOPs, are tools that can help the sprouter systematically evaluate and implement appropriate procedures and controls. Inspectional surveys of the sprouting industry have revealed significant areas of concern in some companies. Recurring problems included potential contamination due to inadequate cleaning of food contact surfaces and equipment, poor personnel practices, poor general maintenance, inadequate plant construction or design, lack of temperature controls, and inadequate pest control. All of these problems can be addressed by adopting GMPs and consistently following SOPs and SSOPs. SOPs and SSOPs are voluntary programs. SOPs are procedures developed by the sprouter, describing how things should be done in their own facility. Although an industry association or other party may develop SOPs, they need to be adapted for each specific facility. At a minimum, sprouters should consider developing SOPs for seed receiving and storage procedures, ensuring and maintaining water quality, sprouting procedures, temperature control, microbiological controls, pest control, packaging procedures including methods and controls, and recall procedures. When the standard procedure is not followed, reasons for the deviation should be clearly identified. An example might be equipment breakdown. Each employee should clearly understand every SOP involving them or their work area. This can be achieved by implementing continuous training programs. Why are SOPs important? SOPs help the entire firm operate consistently. This provides a recipe to follow for what should be done and what has been done. Time is saved in the long run when a firm follows its SOPs. Included in the handout materials is a self-inspection guidance document for sprout growers that was prepared by the California Department of Health Services Food and Drug Branch. Performing a self-inspection helps you identify problems and test proposed solutions. SSOPs are another ingredient in the alphabet soup. SSOPs are sanitary standard operating procedures. They are instructions or procedures for sanitary practices developed by the sprouter for each specific cleaning and sanitation operation. They identify what to clean, how to clean and sanitize, when to clean, and who should clean. Why are SSOPs important? Proper sanitary controls and procedures identify problems and their sources before they cause illnesses and injuries. Once problems are found, they can be corrected. Suitable cleaning and sanitizing prevents product contamination from unclean equipment, utensils, and facilities, thus reducing liability. One example of a guideline is the Guide to Minimize Microbial Food Safety Hazards for Fresh Fruit and Vegetables, which was published in 1998. This guideline provides recommendations on good agricultural practices, GAPs, and good manufacturing practices, GMPs. It addresses microbial food safety hazards and good agricultural and management practices common to fruits and vegetables sold to consumers in raw form. The voluntary guidance document was prepared in close cooperation with the agricultural community. GAPs apply in the area of seed production and conditioning. Seed for sprout production should be grown according to good agricultural practices that minimize the likelihood that they will contain pathogenic microorganisms. A sprouter should know as much as possible about the source of the seeds and verify that they have been grown and harvested in a manner consistent with the GAPs. The GMP section of this guide provides information on facility sanitation, employee hygiene, training, and pest control for the packing house operation. These basic principles can also be applied to the seed conditioning and storage facilities and the sprouting facility. Two related guidance documents are the Reducing Microbial Food Safety Hazards for Sprouted Seeds and Sampling and Microbial Testing of Spent Irrigation Water During Sprout Production. These guidance documents are intended to provide recommendations to suppliers of seed for sprouting and sprout producers about how to reduce microbial food safety hazards and to ensure that sprouts comply with the food safety provisions of the Federal Food, Drug, and Cosmetic Act. The first guideline identifies the most important steps, such as good agricultural practices, seed disinfection treatment, and microbial testing for reducing the likelihood of sprouts as a vehicle for foodborne illness. The second document is intended to assist sprouters in implementing one of the principal recommendations in the broader guide, such as microbial testing of spent irrigation water. Recommendations in the Sprout guidance documents will be discussed at different points throughout this video, and the documents have been included in the materials that came with this video. Another food safety control measure is hazard analysis and critical control point, known as HACCP. It is a preventative program that focuses entirely on food safety and builds upon a strong GMP program. HACCP evaluates a processing operation and identifies the microbiological, chemical, and physical hazards with established critical control points and frequent monitoring and verification. HACCP programs are a mandatory part of meat, poultry, and seafood production, but HACCP is not currently required for other foods. Just as one cannot sanitize without first cleaning, HACCP cannot be properly implemented without a foundation of adherence to GMPs. Traceback cannot prevent foodborne illness from occurring. However, being able to trace a food back to its source quickly can limit the public health and economic impacts of an outbreak. Sprouters, seed producers, conditioners, and distributors should develop and implement systems to facilitate tracebacks and recalls in the event of a problem. All parties should test their systems in advance of a problem. Traceback typically begins with the sprouts and works back to a facility or a lot of seed. This information can often be used to aid in prevention of future illness outbreaks. Recall procedures are developed and used by a sprouter to withdraw product that is already in the marketplace. A sprouter should be able to track all activities and products. Records should be orderly, maintained, and easily retrievable. It is good procedure to periodically test the firm's ability to retrieve information from the records. Can the seed source, production, and distribution records for a specific lot of sprouts be recovered in less than 1 hour? Lot coding sprout products by date code or other coding may facilitate recovery of the product if a recall is needed. Records help put the puzzle together to identify the seed source with related production records and date code. What are the consequences in the event of an outbreak that implicates the product? Without records, the entire outgoing product is suspect. All of the production procedures are suspect. More questions are raised than can be answered. Is the pathogen limited to only 1 day, 1 week, or 1 month of production? Is the source of the problem the seed or employee practices? Has dirty equipment caused product cross-contamination? With SSOPs and sanitation checklist records, the effect of a recall could be limited to a short time period if records show a thorough and complete cleaning and sanitation is done regularly. If a sprouter has accurate records of cleaning and sanitation, well-trained employees, consistent and appropriate use of seed disinfection treatments, and negative lab results on a lot-by-lot basis, they will greatly reduce the likelihood of being involved in an outbreak. You cannot build food safety without meeting the standards outlined in the Good Manufacturing Practices. Understanding the requirements for sprouters has been the focus of this segment. The ingredients in the alphabet soup all play a role in food safety. GMPs are the standards that sprouters should follow in producing food. Once a sprouter has GMPs firmly established, SOPs and SSOPs can be used to ensure that manufacturing and sanitation procedures are performed consistently. These procedures will reduce the chances of problems occurring and will assist both the sprouter and regulator in identifying and correcting the situation if problems do occur. As previously mentioned, once GMPs are in place, additional food safety programs such as HACCP can be developed. HACCP is a technique and a thought process that treats the production, storage, distribution, and service of food as a continuous system. This system is broken down into its logical components, and each is evaluated by principles of failure analysis. The premise is simple. If each step of the process is carried out correctly, the end product will be safe food.
Contaminated seed is the likely source for most reported sprout-associated outbreaks. Knowing as much as possible about where and how the seed was produced and handled can increase the chances of starting with clean seed. In this module, we will help you be aware of the questions that need to be asked of seed growers, conditioners, and/or suppliers. It may also help in understanding some of the constraints growers face in producing seed for sprouting. A multitude of field and vegetable crop seeds are sprouted for human consumption, such as alfalfa, clover, onion, radish, broccoli, lentils, and mung beans. Seed for sprouting is produced throughout the world, but the major suppliers are in the U.S., Canada, and Australia. Crop production practices vary with the type of crop and the area where it's grown. In this review, we will use alfalfa seed as an example, but many of the factors discussed, such as potential sources of contamination and good agricultural and manufacturing practices to minimize contamination, will apply to any type of seed. Approximately 80 million pounds of alfalfa seed are produced each year in the United States. The primary market for that seed is planting stock to produce forages to support livestock. Only a small fraction of the seed produced is used for sprouting. If the seed growers are unaware that the seed is to be used for human consumption, they may unknowingly use agricultural practices that create a potential health risk. Potential sources of contamination are present in the field and in the harvest equipment, as well as at the conditioning, seed supplying, and/or sprouting facility. Although the precise method of contamination of seeds is not known, some possible sources of contamination include agricultural water, animal waste or manure, poor sanitation of equipment, or poor personal hygiene. Contamination of seed may be sporadic and at low levels, but once pathogens are present, they are likely to survive for extended periods of time under normal seed storage conditions. Therefore, it's important to reduce the risk of contamination as much as possible at each step in the production, conditioning, and distribution process. FDA's Guide to Minimize Microbial Hazards for Fresh Fruits and Vegetables addresses common sources of contamination in an agricultural environment and ways to minimize them. A summary of that guide is included with this video. Seed distributors and sprouters buying seed directly from growers should ask questions to ensure GAPs were followed before purchasing seed for sprouting. Buyers may utilize contracts with growers or conditioners that specify good agricultural and manufacturing practices to reduce the possibility of contamination. For alfalfa seed and other perennial crops, the season begins when the forage that has grown during the winter or early spring is removed in an operation called clipback. If there's enough forage or plant material present and previous chemical use doesn't restrict it, this clipping can actually be a hay harvest. In some areas, sheep are brought into the seed fields to remove this winter growth. However, manure from sheep and other animals can be a source of human pathogens. If the seed from the field is destined for the sprout market, sheep should not be allowed to graze. If sheep have grazed the field, the seed should not be used for sprouting. Growers may use commercial fertilizers and/or manure to maintain the fertility of the soil for maximum crop production. The application of manure should be avoided during the production of a seed crop for sprouting. If manure is used, growers should follow good agricultural practices, such as composting and maximizing the time between application and harvest to minimize microbial hazards. The use of untreated manure or raw manure should be avoided. Drift or runoff from adjacent fields where manure is used, from nearby manure storage or treatment sites, or animal production areas may also be a source of contamination. All crops require water. In some areas, water supplied through rainfall is supplemented by irrigation. Growers use a diverse variety of water sources, including canal water and well water, to irrigate their crop. It's applied to the surface of the soil by flood, furrow, or sprinkler irrigation systems. If the seed is to be used for sprouting, growers should evaluate the quality of their water source and follow appropriate good agricultural practices, such as runoff control and animal exclusion, to ensure and maintain water quality. In the field, the seed is protected from contamination by the seed pod, but once harvest begins, the seed is exposed to a substantial amount of dirt and debris. Mechanical damage is also an important issue. Any damage to the seed coat caused by harvest equipment could aggravate contamination by making removal of pathogens during subsequent steps more difficult. In many areas, when seed is grown for commercial planting stock, it's desiccated using chemicals that dry the standing crop in preparation for harvest. However, if seed is to be used for sprouting, chemical drying agents should not be used. Rather, the crop should be cut at the base of the plant and laid in long rows to air dry. A standard combine is used to pick up the crop in the windrow and thresh the seed from the pod. The equipment should be carefully adjusted to separate the very small seed from a large amount of plant material without damaging it. The equipment should also be adjusted to minimize soil uptake during harvest. Seed goes from the combine into bins or a truck for transport to the conditioning facility. If the seed is destined for the sprout market, it should be transported in a manner that will minimize contamination from soil, manure, animal, and rodent urine. Seed should be protected with a tarp during storage and shipping. Conditioning is the process of cleaning the seed to remove weed seeds, debris, and dirt. Equipment such as an air screen cleaner, specific gravity separator, velvet rolls, disc and cylinder separators, and/or a spiral separator may be used. As with the harvest process, conditioning has the potential to damage seed and to spread localized contamination throughout the seed lot. It's important to limit sources of contamination and minimize the risk of cross-contamination in the conditioning facility. Seed, cleaning equipment, storage bins, and supplies, such as shipping bags, should be protected from contamination by rodents, birds, insects, and reptiles. If seed is damaged and pathogens are present, they can lodge in cracks in the seed coat and may make subsequent seed disinfection more difficult. Thus, seed conditioners should make every effort to separate out damaged seed and to minimize damage to seed destined for sprouting. Seed damage may be inadvertent, such as improper settings or overloading of equipment, or it may be purposeful, as in scarification. Scarification is the scratching of the seed coat to improve the percentage and uniformity of germination of a seed lot with a high hard seed percentage. A number of different techniques, chemical and physical, may be used. Once the seed is cleaned, it's stored in the warehouse in bulk bins or bags prior to distribution. During storage, seed should be protected from contamination by animals, insects, or agricultural or industrial wastes and chemicals. Good manufacturing practices, GMPs, for seed storage include storing seed in closed, impermeable containers in a clean area dedicated to seed storage. Containers should be positioned in such a way that contact with contaminants is minimized and regular inspection is possible. Visual inspection of the seed and the area between and around storage containers allows monitoring of pest problems and timely control if necessary. Most seed is distributed to suppliers and sprouters in 50-pound bags. The bag provides one of the first lines of defense against post-harvest contamination. Clean bags should always be used if the seed is destined for sprouting and stored in a clean environment. Seed suppliers and sprouters should purchase seed in bags or other containers which clearly and prominently display the following information: supplier information, lot number, seed type, germination and purity, date of harvest, seed company, and/or country of origin. The lot number is important in maintaining the identity of the seed and, if recorded, facilitates tracking the seed from the grower's field to the conditioner, supplier, sprouter, and back again. The lot number may be found on a tag attached to the bag, or it may be printed directly on the bag. The conditioner may test individual seed lots for purity and germination. Screening for the presence of pathogens is not typical, although some seed distributors are beginning to adopt seed testing programs. Often, seed goes through one or more distributors before reaching the sprouter. At each step of the distribution chain, seed should be visually inspected for evidence of contamination, including insects, water stains, and presence of rodent or bird droppings. Additionally, a black light can be used to detect product that has been contaminated with rodent urine. Bags of seed that have been contaminated with rodent urine will glow. If evidence of contamination is found, seed should not be used for sprouting. After inspection, seed should be stored in a clean and sanitary area. Stored seed in surrounding areas should be inspected frequently to ensure that pests, including rodents, are not present. The definition of a lot is important. Currently, a lot may be defined as all of the seed from a specific field or a truckload. It may also be defined as all the seed of a given variety from a grower's farm. In addition, some suppliers may mix various quantities of seed and assign a lot number to that container. Assigning a lot number to the smallest discrete unit helps limit the amount of seed that might need to be recalled in the event of a problem. Some suppliers mix seed lots to adjust quality factors, such as percent germination, or to increase the size of the lot. However, mixing lots is not recommended because it may spread contamination and hampers traceback. Some seed from other countries may be mixed prior to arrival at the distributor. Suppliers should make every effort to ensure that they know the precise origin of the seed they sell for sprouting and that the information is also passed to the buyer. Because of recent food safety concerns associated with sprouts, it's strongly recommended that suppliers establish a sampling plan and criteria for seed sold to sprouters. Suppliers should first examine samples from desired seed lots prior to committing to purchase. If the seed sample passes the initial examination and the lot is purchased, it should be re-examined thoroughly upon arrival. Sampling procedures should be established to ensure examination is as representative as possible of the entire lot. Visual seed examination uses magnification to look for evidence of rodent droppings, excreta, fungus, molds, or a large number of cracked and broken seeds. Seed samples should also be evaluated under black light for signs of urine. This is in addition to examining seed bags upon arrival and periodically during storage. Some distributors are beginning to test seed for pathogens such as E. coli 0157H7 and Salmonella. Contamination of seed is probably at low levels and sporadic. Sprouting seed first and then testing either the water or the sprouts may increase the likelihood of finding pathogens, if they are present. Microbial testing procedures are described in more detail later in this video. While a negative result does not guarantee the absence of pathogens, a positive result would allow a supplier to ensure the seed is not sold for sprouting. If microbial tests are done, seed should be held in quarantine until the results of testing show no contamination. Results of seed testing should be maintained by lot number. Sprouters should ask suppliers if seed has been tested for pathogens and which tests were done. The more testing that is conducted, the better the chances of detecting a problem if it exists. Using good quality seed is an important step towards producing the safest possible product. Everyone needs to establish safeguards that prevent contaminated seed from entering the food chain. Individual sprouters need to develop a relationship with their seed supplier and insist upon receipt of clean seed from a reliable source. Seeds for sprout production should be grown, conditioned, stored, and transported under conditions that minimize exposure to pathogens. Good agricultural practices should be systematically implemented to reduce the potential for contamination of seeds for sprout production. Increasing awareness of the potential for contamination from the field through the sprouting facility and implementing GAPs and GMPs to improve handling of seeds and sprouts will reduce the risk of foodborne disease. Additional recommendations for producing sprouts are contained in the following modules.
Recent surveys of sprout growers in California and across the United States identified a broad variety of production practices, including types of facilities, types of seed sprouted, and pounds of sprouts produced. For example, the surveys reported sprouts being produced in buildings, sheds, greenhouses, modified buses, agricultural fields, or a combination of these. Firms were producing about 50 different kinds of sprouts. The most frequently observed products were mung bean, alfalfa, clover, and radish sprouts. Most firms were relatively small operations, producing less than 15,000 pounds of sprouts per week. These surveys also identified one or more problems with sanitation and hygiene in at least half of the sprout production facilities visited. Although seed appears to be the primary source of contamination in sprout-associated foodborne illness outbreaks, poor sanitation and inadequate hygiene at the sprout facility will increase the likelihood of sprout-associated foodborne illness. This module will present an overview of one way to produce sprouts the right way. The sprouting facility should be clean, well-maintained, and enclosed. Facility layout should allow separation of seed storage, production, and packaging areas. Traffic flow within the facility should be such that employees are moving from the cleanest areas first, like product packaging, to less clean areas, like seed storage, and not the other way around. Additional information on requirements and recommendations for facility construction is provided in Module 2 and in the GMP materials accompanying this video. Plant cleaning and sanitation are covered in Module 3E. Appropriate personnel practices are discussed in Module 4. Each of these factors should be firmly in place before production begins. Signs should be clearly posted at the entrance of the facility and at relevant locations throughout the facility to ensure visitors and employees are aware and reminded of company policy about hygiene and sanitation. Sprout production consists broadly of the steps shown here. Some firms may add to or omit some of these practices depending on a number of factors, including the type of seed being sprouted and the size and resources of the firm. Seed is usually received by the firm in bags or sacks. 50-pound cloth bags are most common. Seed suppliers should visually inspect all bags and pallets upon delivery for evidence of contamination, including insects, water stains, and presence of rodent or bird droppings. Bags of seed that have been contaminated with rodent urine will glow when viewed using a black light. Seed sacks and seed that show signs of contamination or excess filth should be rejected. As mentioned in the preceding module, producing a safer product starts with using good, quality, clean, intact seed. Sprouters should purchase seed only from reputable suppliers. They should have good communication with their suppliers and should know as much as possible about where and how their seed was produced. Seed bags usually bear a tag listing the following information: supplier name, supplier address, lot number, seed type name, and country of origin. Sprouters should retain these to facilitate traceback in the event of a problem. If microbial testing of seed is done, either by the supplier or the sprouter, results should be reviewed. The seed storage room should be clean and sanitary and separate from the rest of the facility. It should not be used to store equipment, chemicals, or personal items. Storage area temperature and humidity should be controlled. Seed stores best in a cool, dry environment. A good rule of thumb is a combination of heat and humidity that equals 100. For example, room temperature of 70 degrees and 30% humidity. Seed should be stored off the floor and away from walls to reduce the likelihood of rodent contamination and facilitate inspection for signs of rodent contamination. Open bags should be stored in a receptacle with a tight-fitting lid or otherwise protected from contamination. Seed containers and the surrounding area should be inspected on a regular basis to monitor for pests, and a pest control program should be in place. Seed lots should be kept separate to facilitate traceback should the need arise. Seed lot number should be noted and recorded for each batch of sprouts produced. Seeds have been identified as the source of contamination in most sprout-associated outbreaks. Therefore, it is important that sprouters apply an approved disinfection treatment to seed immediately before sprouting. Currently, 20,000 parts per million calcium hypochlorite is recommended for treating seed. Seed disinfection will be covered in more detail later, but the basic steps look like this. Employees handling calcium hypochlorite should take appropriate safety precautions, including wearing protective clothing. A fresh 20,000 parts per million calcium hypochlorite solution should be made for each batch of seed. Carefully follow all label instructions when mixing and using calcium hypochlorite solution. Additional references are available in the accompanying handouts. It is important to use the correct amount of solution for a known quantity of seed. Too much seed or too little solution will decrease the effectiveness of the treatment. A mixture of 1 gallon of solution for 5 pounds of seed should be used to ensure adequate antimicrobial activity. Weigh out a known quantity of seed into an appropriate container and pre-wash the seed with potable water to remove any dirt or debris and then drain. Add the 20,000 parts per million calcium hypochlorite solution to the cleaned seed and stir for 15 minutes at room temperature. Pour off the used chlorine solution and dispose of according to state requirements. Treated seed should be rinsed with potable water for 10 minutes, changing the water several times as necessary to remove any residue. After disinfection treatment, seeds to be grown in trays are generally pre-soaked in potable water to initiate sprouting. Seeds grown in drums are generally not pre-soaked but placed directly in rotary drums. If seeds are pre-soaked, the soak time should be as short as possible to minimize the opportunity for microbial growth. For some seeds, 1 hour is sufficient. After pre-soaking, seeds should be rinsed with potable water to remove residues from soaking. Methods used for germination and growth and subsequent harvest and washing vary depending on many factors, including the size of the operation and the type of sprout grown. Sprouters may use rotary drums, trays, growing rooms, or soil trays. Soil trays have some special considerations that will be covered later in this module. Germination and growing times vary with type of sprout, time of year, and germination process used. For example, alfalfa and clover 3 to 7 days, broccoli 4 to 7 days, mung beans 3 to 8 days, radish 3 to 14 days, and wheatgrass 3 to 14 days. Germination processes fall into 2 general categories: rotating drums or trays on racks, generally in a lighted room, and stationary containers, for example bins, beds, or buckets, in environmentally controlled rooms or freestanding growth chambers which are often kept dark. In addition, some sprouters germinate sprouts in drums, allow up to 60% of growth to occur, then rinse the sprouts and transfer them to trays, cups, or final packages, such as clamshell-type packages, on a tiered table or rack to finish growing. With this process, sprouts will grow in a more vertical, uniform manner. When purchasing new equipment or remodeling facilities, food safety and ease of cleaning should be a primary concern. Rotating drums are usually hard plastic cylinders measuring approximately 5 feet in diameter by 5 feet deep. Drums are positioned sideways and off the ground with a chain or belt attached to the back of the drum for rotation. Rotation keeps sprouts separated and prevents clumping. The inside of the drum is typically partitioned into quarters with the same plastic. As discussed elsewhere in this video, drums should be designed in a way and constructed of materials that make cleaning easy. Drums and all equipment should be positioned in a way that facilitates cleaning. Typically, alfalfa, broccoli, clover, and radish seed are sprouted in rotating drums. Each drum can hold 8 to 100 pounds of seeds, although 10 pounds of seed per quadrant is most common. Once the seed is placed in the drum, the lid is closed and the drum begins to rotate. Water is sprayed intermittently on the seed to keep the sprouts from overheating, to remove byproduct residues of growth, such as ethylene gas, and to irrigate the product. For instance, seed may receive a water spray every 10 to 15 minutes for 10 seconds. Sprouters should use potable water for irrigation. Air may be blown into the drum to keep the product ventilated. Care should be taken to ensure air does not contain contaminants, such as dust and mold, that can contaminate product. Mung beans and soybeans are generally grown in bins or beds in separate rooms. Rooms are kept dark, humid, and with temperatures between 70 to 79 degrees Fahrenheit. An intermittent spray, for example, less than a minute every 4 hours, is applied either manually with a hose or by an automated watering system. Buckets, bins, barrels, or beds should all be raised off the floor to prevent contaminants from splashing onto the product. During the sprouting process, samples of irrigation water or sprouts should be tested for pathogens, E. coli, O157H7, and Salmonella. Samples should be collected at least 48 hours after the start of sprouting, but no later than 48 hours before harvest and packaging to allow the sprouter to obtain results before the product is shipped. It is important that persons collecting samples understand aseptic sampling procedures to avoid contaminating samples and know how to label and package samples for transport to a laboratory. It is strongly recommended that all testing for pathogens be done by an external, qualified, independent laboratory. Additional details on sampling and testing procedures are contained later in this video. When sprouts have reached the desired stage of growth, they are removed from growing containers or harvested. Depending on conditions and the rate of growth, sprouters may harvest a little sooner than expected, or they may let the sprouts grow a little longer. This variability should be figured in when planning when to sample for microbial testing. All equipment used to transfer seed to growing containers and to harvest sprouts should be cleaned and sanitized. Equipment and tools should be stored between use in a clean and sanitary condition. Tools should not be placed on the floor or used for other purposes. During harvest and washing, sprouts should be handled with clean and sanitary equipment. After sprouts are removed from the growing container, they are washed with cool water to remove excess hulls. Washing with cool water also helps bring down the temperature of the sprouts. Sprouts may be washed in a bucket of water and sieved through a hand screen, or they may be placed in a bubbling tub of water to loosen and float off hulls. Occasionally, sprouts are washed in recirculating water in a flume system. If water is reused for washing successive batches of sprouts, water treatment systems and monitoring devices should be in place to maintain water quality. After washing, sprouts are usually spin-dried using a centrifuge for 1 minute, or in some instances, a clothes dryer for 2 minutes. Sometimes sprouts are placed in a cold room between harvest and packaging to remove heat generated during the sprouting process. Anytime sprouts are cooled in a cold room, they should be placed in small, shallow containers to allow for rapid cooling and to minimize the potential growth of pathogens. Sprouts in a large container, such as a 20-gallon barrel, may take several days to cool. When cool and dry, fully germinated sprouts are ready for packaging. Some firms grow sprouts in soil. This practice carries some additional considerations. If a sprouter is growing sprouts both in soil and hydroponically, soil-grown sprouts should be grown in a separate room from hydroponic sprouts to avoid cross-contamination. Tools and equipment used for soil-grown sprouts should not be used for hydroponic sprouts. Personnel should change boots and clothing and wash hands after working with soil-grown sprouts and before entering other areas of the facility. Seed used for soil trays is soaked and rinsed as described earlier for hydroponic operations. After rinsing, wet seed is usually held in buckets to allow for initial germination. Again, this should be kept to as short a time as possible to minimize microbial growth. While seed is soaking, plastic trays are filled with soil. Sprouters growing sprouts in soil should choose a growing medium, for example, sterilized potting soil, that does not contribute to food safety concerns. Manure, even composted manure, should not be used. Pre-soaked seeds are spread on top of the soil and leveled out. Growing usually takes place in a greenhouse. Water is sprayed on trays usually 2 times daily by an automated pipe system overhead. Sprouts can take 5 to 10 days for optimal growth in wintertime or 3 to 10 days in summertime. Most soil-grown sprouts are harvested at the facility, washed, packaged, and delivered to the customer. Typically, soil-grown products are brought into a cutting and packaging room in soil trays. Ideally, soil-grown sprouts will be packaged in a separate area that is cleaned and sanitized between use. If the same room is used to package soil-grown sprouts and other sprouts, soil-grown sprouts should be brought in alone, for example, when no other product is being packaged. All surfaces that come in contact with soil or soil trays should be thoroughly cleaned and sanitized before other product enters the area. Some sprouters do not harvest soil-grown sprouts at the facility, but place the sprouts and soil tray in a plastic bag and deliver the product directly to the retailer. At the retailer, the tray is placed in a cooler. Typical retailers of this product are juice blending shops. These shops cut sprouts, primarily wheatgrass, directly from the tray and drop them into a blender with other fruits, vegetables, and various ingredients. When the retailer is finished cutting sprouts from the tray of soil with remaining roots is returned to the sprouter. The sprouter may pick up these trays while delivering new trays of freshly grown, uncut product. Trays should be thoroughly cleaned and sanitized before reuse. Some sprouters deposit used soil and remaining sprout parts into a compost mound. However, reuse of this soil for sprout production is not recommended. Packaging should be done as quickly as possible after harvest. Packaging is usually done manually and should be done in a separate packaging room. Packaging materials should be stored in a clean, dry, pest-free environment separate from seed. Only food-grade packaging materials should be used. Since sprouts are living plants and continue to respire, packaging materials should not permit an anaerobic condition to develop. Packaging usually occurs at the growing site. However, occasionally, product is transported in bulk to another location to be packaged. Some firms selling at farmers markets transport the product in bulk and package the product into retail containers as it is sold. It's much more difficult to control conditions at a farmer's market compared to a packaging room in an enclosed facility. Hand washing facilities may not be easily accessible at a farmer's market, and product may be exposed to hot sun and blowing dirt. Such conditions make appropriate handling of potentially hazardous food very difficult. If product is sold like this, special care should be taken to ensure product is kept cold, to avoid bare hand contact with the product, and that utensils used to transfer sprouts to retail containers are clean and sanitary. Sprouts have been designated as a potentially hazardous food in FDA's Food Code. Therefore, if the food code has been adopted in the state, certain requirements need to be met, one of which is maintaining a cold chain or keeping product cold at all times. Packaged sprouts should be placed immediately in refrigerated storage. Cold room temperature should be 41 degrees Fahrenheit or less. Temperature should be monitored and recorded, or a continuous temperature recording device used. Thermometers should be checked regularly to ensure they're working and that they are accurate. Measuring the temperature of the product in the center of the room is a better indicator of product temperature than measuring room temperature. Product should be arranged to allow good air circulation and rapid cooling. Because sprouts are still respiring, they can generate heat, even in a cold room. Small containers and good air circulation help prevent hot spots that may result due to heat generated by the still living sprouts. The cold chain needs to be maintained as much as possible when staging or stacking boxes to prepare for loading delivery trucks. Refrigerated delivery trucks should be cooled before product is loaded. Staging on non-refrigerated docks and/or in the hot sun, and likewise, delivering product to non-refrigerated customer docks breaks the cold chain. If product warms, microorganisms may grow. Delivery vehicles should be clean and sanitary. They should have refrigeration and thermometer gauges, especially if they are going more than a short distance. Remember that delivery times depend not only on distance, but also on the number of delivery stops made. Since sprouts are perishable foods, at retail they need to be held under refrigeration. Once sprouts are harvested, cleaning and sanitation activities should take place prior to the next production run. This is where your Sanitation Standard Operating Procedure, SSOP, becomes especially important. As discussed earlier, an SSOP should detail all steps necessary to properly clean and sanitize your facility, along with instructions for how and how often these steps should be taken. SSOP should detail how all equipment, utensils, and food contact surfaces should be routinely disassembled, inspected, cleaned, and sanitized prior to being placed back into operation. SSOP should also detail how non-food contact surfaces, including floors, walls, and ceilings, are to be cleaned and sanitized. SSOP should include safeguards to ensure that sanitation activities do not contaminate ingredients, finished products, or packaging. SSOP should detail how all chemicals used during sanitation activities are to be stored, measured, handled, and disposed of.
In this module, we will address the seed treatment process. If seeds for sprouting have been grown under good agricultural practices and stored and transported in closed containers, the likelihood that they will be contaminated with pathogenic bacteria will be minimized but not eliminated. Seeds for sprouting should be treated with one or more treatments that have been approved for reduction of pathogens. Some treatments can be applied at the sprouting facility, while others will have to be applied earlier in the seed production process. However, at least one approved antimicrobial treatment should be applied immediately before sprouting. Antimicrobials are either pesticides, chemicals, or food additives. As such, their use on seeds for sprouting should be approved by the U.S. Environmental Protection Agency or the U.S. Food and Drug Administration. Permits for use may be needed. Growers should check with their local officials. The goal of treating seeds is to significantly reduce pathogens that may be present on seeds. The primary pathogens of concern are Salmonella and E. coli 0157H7. Salmonella has been recovered from seeds and from seeds sprouted in a sterile environment. Salmonella was the cause of 11 of the 13 reported outbreaks associated with sprouts from commercial growers. The remaining 2 were caused by E. coli 0157H7. Treatment of seeds in a solution of calcium hypochlorite prepared to contain 20,000 parts per million, or ppm, of active chlorine is recommended. Calcium hypochlorite is specified rather than sodium hypochlorite or domestic bleach because it doesn't significantly reduce permanent germination for most seed types. In recent outbreaks of illness associated with alfalfa sprouts, none of the sprouters could document the use of 20,000 ppm of chlorine to treat seeds. Calcium hypochlorite is the only chemical treatment currently approved by the EPA for disinfecting seeds intended for sprouts at concentrations that can significantly reduce the level of pathogens on seeds. All chemicals used for cleaning and sanitizing, including calcium hypochlorite, should be stored away from areas used for seed storage and sprout production. Storage and handling of chemicals always should be in strict accordance with the label directions for the safety of both consumers and workers. Calcium hypochlorite concentrate obtained from the manufacturer, as well as the 20,000 ppm treatment solution, are chemical hazards. Again, anyone handling this chemical must follow the label directions and take appropriate precautions. Waterproof gloves, chemical-resistant footwear plus socks, protective clothing such as coveralls over a long-sleeve shirt and long pants, and protective eyewear and chemical-resistant headgear for overhead use are essential to protect handlers from hazards associated with calcium hypochlorite. Additional precautionary measures are identified on the chemical label. A fresh solution of calcium hypochlorite should be used for each batch of seeds. Prepare a 20,000 ppm active chlorine solution by mixing 4.1 ounces of calcium hypochlorite powder, which contains 65% available chlorine, with 1 gallon of potable water at room temperature in a well-ventilated area. It's important to weigh the calcium hypochlorite on a scale rather than using a measuring cup. Only by using scales can the proper concentration, 20,000 parts per million, of active chlorine be assured. The solution should be stirred for at least 5 minutes to maximize free chlorine in the solution. Pre-wash seeds in potable water for at least 5 minutes with agitation and then drain the wash water. Treat pre-wash seeds once by soaking 5 pounds of seed in 1 gallon of 20,000 ppm calcium hypochlorite solution with continuous agitation for 15 minutes at room temperature. After treatment, drain the solution and rinse the seeds thoroughly with potable water for 10 minutes, changing the water several times as necessary. Used calcium hypochlorite solution should be diluted with at least an equal amount of water before disposal. For requirements in your state, contact the State Water Board or the regional office of the U.S. EPA. The active chlorine concentration should be measured at least weekly to assure that the desired 20,000 ppm level is present in the treatment solution. The hardness and pH of water used to prepare calcium hypochlorite solution can affect the concentration of active chlorine and may have to be modified if not within acceptable ranges. Hardness results from minerals, especially calcium and magnesium in water. The pH is a measure of acidity or alkalinity. The pH of the prepared hypochlorite solution should be between 6.2 and 6.8. Measurement of the concentration of active chlorine and pH of the solution should be taken from at least 1 batch per week. Commercial laboratories are available to provide this service. If results are outside the accepted range, guidance should be sought from the laboratory. Research is underway to develop and evaluate other methods for disinfection of seeds. These include chemicals, temperature control, irradiation, and a combination of these methods. However, none of these treatments are currently validated, that is, scientifically proven effective, and are not currently authorized or accepted for use on seeds by the FDA and the EPA.
The main reason for microbiological testing is that currently approved antimicrobial treatments cannot guarantee total elimination of all pathogens from seed. Even if only a few pathogens survive a seed disinfection treatment, they can grow to high levels during sprouting. Spent irrigation water from each production lot should be tested microbiologically to ensure that contaminated product is not distributed. Testing irrigation water rather than the sprouts themselves is recommended because it is fairly uniform and requires fewer sample preparation steps and fewer samples compared to sprouts. If the sprouts are grown in soil and spent irrigation water is not available, the sprouts themselves may be tested. The sprouts also may be tested in addition to the irrigation water. It is possible to obtain test results before shipping product without losing product shelf life, because testing for pathogens can be done with irrigation water as early as 48 hours into what is generally a 3 to 5 day growing period. Testing may be done by the producer or contracted out, but it should be done by trained personnel in a qualified laboratory using validated methods. The microbial testing required involves a number of hazards, including growing pathogenic bacteria and disposing of contaminated waste materials. While a variety of microbiological tests might be performed, the main pathogens of concern are Salmonella species and E. coli 0157H7, which have caused sprout-associated foodborne illness outbreaks. Therefore, these will be the target microorganisms.
A sampling plan should be decided upon before sample collection begins. The sampling plan will identify when the samples will be taken. The current recommendation is that samples are taken about 48 hours into the growing period. Next, it will identify the number and size of samples to be taken from each lot. A lot is defined as sprouts from a single lot of seed that were planted at the same time in a single growing unit, meaning a single drum or rack of trays. A lot number reflects the seed used and the production date and time. Careful record keeping will help minimize product loss in the event that a micro-test is positive. Pooling, or combining samples from different lots, will make the interpretation of the results more difficult. If a positive sample is found, all lots represented by the pooled sample should be discarded or held for further testing. Further, pooling may dilute pathogens, if present, to a level where they may not be detected. The sampling plan should also state what test method will be used for each target microorganism. Sample collection should be done by personnel that have been trained to collect representative samples aseptically. A representative sample is one that accurately represents the whole lot. If sprouts are grown in drums or in trays with a common water outlet, a single 1-liter sample should be collected as water leaves the growing unit. If sprouts are grown in trays and there is no common collection point for water from the trays, it will be necessary to collect water from individual trays. The amount taken from each tray should be approximately the same. Collecting the entire sample from one tray would not be representative of the whole lot. Samples should be collected at the beginning of the irrigation cycle, especially when irrigation uses a large volume of water or lasts a relatively long time. Aseptic sample collection means that the procedures are designed to avoid introducing microorganisms from the hands, sample containers, air, or anything except the sample itself. Aseptic procedures are critical to avoid contamination of the sample during sample collection, storage, and transportation. Equipment used to collect samples should be clean and sterile. Sample containers may include pre-sterilized plastic bags, tubes, cups, and flasks. Containers should be properly labeled to identify the sample, lot, time, and date of sampling. Sample collectors should wear a clean lab coat, gloves, and hair covering in order to prevent contamination of the sample by the collector. Any sampling instruments, such as cups or tongs, should be protected from contamination before and during use, and used only once so that each sample is taken with a fresh, sterile utensil. The sample container should be filled about 3/4 full to prevent overflow. Samples should be delivered to the laboratory promptly and not held for any length of time before analysis. Preferably, samples should be stored at temperatures no greater than 40 degrees Fahrenheit if analyses cannot be performed within the first 2 hours after sampling. A sample of spent irrigation water should be collected for each production lot or batch. At least 1 liter of spent irrigation water should be taken as the water leaves the drum or trays during the irrigation cycle. If sprouts are sampled, 32 sample units should be aseptically collected, each approximately 50 grams or about 2 ounces. Sample units should be collected throughout the entire production lot, meaning from top to bottom, side to side, and front to back of the tray or drums. Each 50-gram sample unit of sprouts should be placed directly into individual, clean, sterile, pre-labeled containers to facilitate subsampling at the testing lab. It is strongly recommended that all testing for pathogens be conducted in a qualified, independent testing laboratory that meets several key criteria. As mentioned earlier, such a laboratory should be physically separated from the sprouting facility to prevent cross-contamination of the sprouts from test materials. Conducting these tests requires the use of cultures of pathogenic bacteria, which could pose a hazard both to the workers and the consumers if not done properly. The laboratory should be staffed by personnel with training and experience in analytical microbiology techniques and handling of pathogens. The laboratory should periodically run positive controls to ensure that the tests used are capable of detecting pathogens when they are present. This can be done by adding a known quantity of pathogens to spent irrigation water or sprout samples and then testing these positive samples. The laboratory should have proper equipment and a demonstrated quality management system, including appropriate record keeping and documentation. If testing is done by the sprout grower, then the facilities, personnel, and laboratory management system should also meet all of these criteria. Recommended sampling and testing procedures are described in more detail in the FDA guidance document, Sampling and Microbial Testing of Spent Irrigation Water During Sprout Production, which is included in the written material supporting this video. The procedures were chosen to obtain results as simply and quickly as possible and provide evidence for the presence or absence of Salmonella and E. coli 0157H7. The test kits identified in the FDA guidance document are approved by the Association of Official Analytical Chemists International as screening tests or have been used in the past by FDA. If other methods are used, these alternative methods should also be validated or scientifically proven to give accurate results for this particular application. If chemical intervention treatments are applied to irrigation waters, and note that currently none are sanctioned for use by regulatory agencies, then appropriate neutralization techniques, such as use of DE broth, should be included as part of the testing protocol. The rapid test kits described in the FDA guidance document all require use of an overnight enrichment step to promote growth of the target pathogen to detectable levels. These test kits cannot be used without this enrichment step to detect pathogens in irrigation water or sprouts. The testing procedures recommended by FDA were chosen to obtain results on the presence or absence of Salmonella and E. coli 0157H7 as quickly and simply as possible. They are screening tests. If the results are negative, these results are assumed to be correct. If the result is positive, however, it should be assumed that the product may be contaminated and further action is necessary. The grower should decide on an action plan for dealing with positive results before a positive is found. 2 options exist. The grower should either accept the results of the screening test as true and discard the sprouts from the suspect lot or lots immediately, or ask the testing laboratory to run confirmatory tests and destroy the batch only if the confirmatory tests are also positive for the presence of the pathogen. The product should be held while confirmatory testing is completed. Product with a positive screening test should not be shipped until confirmatory testing has been completed. Rapid test kits are for screening only. Procedures from the FDA Bacteriological Analytical Manual, known as BAM, should be used to confirm positive results from the screening tests. When deciding whether to do confirmatory tests, remember that the extra time required will shorten the shelf life of the sprouts, even if the confirmatory tests are negative. When a batch of sprouts is considered to be contaminated with a pathogen, the seed lot used to produce the sprouts and any other sprout production lots that were made from the same seed lot also may be contaminated and should be discarded. In addition, All equipment that has come in contact with the contaminated sprouts should be thoroughly cleaned and sanitized. The tests for pathogenic microorganisms as described previously may be conducted to screen incoming seeds. Other microbiological tests on seeds may be conducted as microbial indicators of quality. This activity is very often performed by the seed supplier or distributor, and not necessarily by the sprout grower, unless the grower wishes to include it as a further verification activity. Such testing may be written as a specification in the contract to purchase seeds. The effectiveness of testing seeds for pathogens is increased by growing sprouts from a representative portion of seeds from each lot, and testing according to the methods described in the guidance document. However, it is difficult to find pathogens in seed, and negative test results for a seed lot cannot guarantee that the seed is free of pathogens. Tests may also be done to monitor the hygiene and sanitation of the sprout production environment, particularly the effectiveness of pre-operational sanitation of food contact surfaces and non-food contact surfaces such as floors, walls, and drains. Indicator organisms such as generic E. coli and total Enterobacteriaceae, or possibly the coliform group, may be sought for this purpose. Another type of test may be used to assess the general cleanliness of the facility and equipment surfaces using a technique known as ATP bioluminescence. Microbial testing may also be performed to monitor the hygiene and microbiological quality of in-process product, sprouts at different stages of growth, or irrigation waters, by testing for generic E. coli. Such monitoring activities are useful to identify trends in the quality of raw material and to assess the cleanliness, sanitation, and hygiene of the production environment. Results of such monitoring can be used to plan for improvements in effectiveness of quality and/or sanitation controls. Additional information is included in the accompanying handouts. In this module, we have learned why it is important to test irrigation water for pathogenic bacteria, how to take samples of spent irrigation water and/or sprouts for microbiological analysis, who should perform the tests, how to interpret the results, and what action to take if a positive is found.
All equipment, utensils, and food contact surfaces in the processing facility should be cleaned and sanitized on a daily basis or more often if needed in order to prevent the adulteration of food products. Food contact surfaces are all surfaces that touch or are likely to touch sprouts. Surfaces that could indirectly contact sprouts are also considered food contact surfaces. In order to properly clean and sanitize equipment, utensils, and food contact surfaces, it's important that they be adequately constructed and maintained. The materials used for equipment, utensils, and food contact surfaces should be non-toxic, durable, and non-absorbent. In addition, equipment should be designed to be accessible for cleaning and sanitizing, or be easily disassembled to allow for cleaning and sanitizing. It's important to understand the difference between cleaning and sanitizing. Even though many people believe them to be synonymous, they are really two completely separate steps in an effective operation. Cleaning is the removal of organic material and debris from surfaces in preparation for sanitizing. Cleaning involves washing and rinsing and is usually done with detergents and soaps and physical scrubbing or agitation, followed by a potable water rinse. Sanitation is the reduction of pathogens and other microbes from the surfaces that have been cleaned using various means such as chemicals, heat, or other antimicrobial agents to yield a 99.999% reduction of pathogenic microorganisms. In order to properly conduct cleaning and sanitizing activities and to maximize the effectiveness of those activities, there is an order in which those activities should be conducted. First, any equipment that needs to be disassembled prior to cleaning should be taken apart. All surfaces should then receive a pre-rinse with potable water. Next, all surfaces and equipment should be effectively cleaned using hot water, at least 110 degrees Fahrenheit for manual wash, detergent, high pressure, or scrubbing as necessary. There are several factors that will influence the effectiveness of any cleaning program. For example, equipment pre-rinse, the type, strength, and temperature of detergent solution, exposure time, and the amount of physical scrubbing. The detergent soap then should be completely rinsed off with potable water. Next, All surfaces should be sanitized with an antimicrobial agent approved for use in a food processing facility. Commonly used sanitizers include chlorine, quaternary ammonium, or iodine. It's important that the level of sanitizer be adequate to kill pathogens. When using chlorine, a level of 100 to 200 parts per million is considered acceptable. For safety and effectiveness, it's critical to follow label instructions when mixing and applying the sanitizers used. All sanitizer levels should also be checked and recorded. There are also several factors to consider when choosing a sanitizer, such as what type of equipment or surface is to be sanitized, the temperature of the sanitizing solution, the pH and the hardness of the water in the facility, as well as the contact time of the sanitizer. When in doubt, consult with the chemical suppliers for guidance in the choice of detergents and sanitizers. Your SSOP should also detail what chemicals are to be used for each job, how and when they are to be mixed and applied, as well as all precautions to be taken when using each chemical. All chemicals should only be used as labeled and when safe. All chemical containers should be labeled properly. All chemicals should be stored in such a manner so as to not contaminate food, seeds, ingredients, or packaging. Chemicals should not be stored on food contact surfaces and should not be stored in empty food or ingredient containers. Seeds or sprouts should not be stored in a container that previously stored chemicals. Check the labels of all chemicals and do not hesitate to contact the chemical supplier if you have questions. All cleaning and sanitation activities should be reviewed by a supervisor. This provides for uniformity in these activities and allows for changes if needed. If you have a written SSOP, it can help ensure procedures are adequate and consistently performed. Sanitation standard operational procedures detail how workers are to clean and sanitize, how sanitizers are to be used and mixed, and how and when tasks should be completed. SSOP should also detail how and where equipment and utensils are to be used and stored. The SSOP should be reviewed by management periodically and be updated as needed. Another way to check on the effectiveness of all cleaning and sanitation activities is to conduct environmental monitoring. There are various types of monitoring, such as bacterial swabbing and the use of luminometers that use bioluminescence in showing whether a surface has been cleaned and sanitized properly. Luminometers measure the amount of organic matter that may be left on food contact surfaces after inadequate cleaning and sanitizing. The amount of organic matter is read in the form of numbers from 1 to 6, with anything under 2.5 being considered acceptable. This form of monitoring allows for immediate feedback and can pinpoint problem areas that need more thorough attention. Firms may conduct these monitoring activities in-house, or they may choose to hire an outside lab. Outside labs should be qualified by the proper authorities in order to conduct monitoring activities. Check with your local or state authorities for qualified labs in your area. If a firm chooses to monitor in-house, proper procedures should be followed at all times, and all monitoring should be documented and verifiable. It's always recommended that whatever methods used provide accurate results. The importance of acceptable equipment construction in proper cleaning and sanitizing activities can be summed up in one word: biofilm. Some common examples of biofilm in everyday life might include the plaque which can grow on our teeth, or the algae in a stream growing on river rocks. As it relates to sprouts, biofilms are a collection of bacterial cells that attach to equipment and other surfaces in food plants and surround themselves with a protective layer of complex carbohydrates. Various pathogens such as Listeria, Salmonella, and E. coli 0157H7 have been shown to form biofilms that can contaminate food products during production. Biofilms can be found on the surfaces of product lines, growing trays or drums, spinner baskets, stainless steel and plastic conveyor systems, and any food contact surface. Bacteria in biofilms are difficult to detect and control. Once established, the bacteria in biofilms are extremely resistant to sanitizers, disinfectants, and heat treatment. However, biofilms take days to build up. Timely and proper cleaning and sanitizing can deactivate the bacteria in the early stages of formation. Sanitation workers should carefully follow all cleaning steps: pre-rinse, clean, post-rinse, and sanitize every time. The cleaning crew should also carefully follow the directions for the concentration, temperatures, and contact times for all cleaners and sanitizers. They should ensure that those cleaners and sanitizers used reach all food contact surfaces. This can be accomplished by inspecting all equipment and surfaces after cleaning, both visually and through microbiological monitoring of the environment. Following the SSOPs is critical in controlling biofilm formation. It's also important that any rusty, pitted, or deteriorated equipment and food contact surfaces be repaired or replaced. Rust and deteriorated equipment allow for the growth of bacteria and become difficult to clean, which makes the formation of biofilms very easy. Pests can and do contaminate foods and transmit disease. Safe and effective control and exclusion is a priority. All insects, rodents, and birds, as well as domestic animals, should be excluded from the facility at all times. Proper pest control and exclusion can be separated into two categories: physical controls and chemical controls. Physical controls include items such as window screens, screen doors, proper weather stripping of all doors, plastic curtains, and air fans at all doorways. Even the practice of keeping all doors closed serves as a physical control. Proper removal and storage of waste products from the facility, removing old, unused equipment, and maintaining the exterior grounds surrounding a facility all serve to remove possible vermin attractants. Keeping a cleared space around the exterior perimeter of the building is also helpful. Proper storage of ingredients, finished products, and packaging, as well as the timely cleanup of spills and the proper lighting of the facility, all help in discouraging vermin infestations. Chemical controls consist of the use of pesticides, traps, and baits in and around the facility. It's suggested that a licensed pest control operator conduct these activities. Any chemicals used in pest control applications should be acceptable for use in a food processing facility, and their application should not contaminate foods, ingredients, or food packaging. All pest control chemicals should be stored properly. They should not be stored on food contact surfaces or in any areas of the facility where they could contaminate ingredients, finished products, or packaging. All pest control activities should be routinely monitored and recorded. Proper monitoring will show the effectiveness of those activities and can identify areas that need more attention. Remember, chemical controls can only be effective when used in conjunction with well-established physical controls. The primary goal of a successful pest control program is to exclude all pests.
People can harbor pathogens on their skin and hands and in their digestive system or respiratory tract. Ill food workers not properly washing their hands and having bare hand contact with ready-to-eat foods are among the most important causes of foodborne illness outbreaks. Human contamination of the sprout during any phase of the growing process, from germination through packaging, can be the cause of an outbreak of foodborne illness. Current good manufacturing practices require that everyone working in direct contact with food, food contact surfaces, and food packaging materials should adhere to good hygienic practices to protect against contamination of the food. Personal hygiene includes good health habits such as bathing regularly, washing hair, wearing clean clothing, and frequent hand washing.
Human hands are used for more than just handling sprouts. They may be used to greet others, to comb hair, eat, to scratch, to handle unsanitary objects, and they are used when using the toilet. When engaged in these activities, hands may become contaminated with harmful microorganisms and in some cases harmful chemical substances. These microorganisms or chemicals can be passed to the sprouts or sprout contact surfaces if effective hand washing techniques are not employed. Employees should know when and how to properly wash their hands. Fingernails should be trimmed, filed, and maintained so that hand washing will effectively remove soil from under and around them. Hands should always be washed before food preparation, after touching human body parts, after using the toilet, after coughing, sneezing, using a handkerchief or tissue, after using tobacco, eating, or drinking, after engaging in any activity that may contaminate the hands, such as taking out the garbage, handling cleaning chemicals, or picking up dropped items, or after caring for or touching animals. Improper hand washing is as potentially hazardous as no hand washing at all. Training programs should be designed to help employees understand exactly what is expected of them and why it is important, and should demonstrate proper hand washing techniques. New employees should receive training prior to beginning employment. Principles of personal hygiene and sanitation should be periodically reviewed with all employees. Prominently placed signs or posters are a good reminder. Clothing worn by employees in food processing and production areas should be kept clean. Dirty and soiled clothes can be a source of contamination of food products. Clean uniforms, aprons, or other outer garments that are put on after the employee gets to work can help to minimize contamination from sources outside the processing facility. Clothing, food for meals or snacks, or other personal belongings should not be stored in areas where food is exposed or where equipment or utensils are washed. Clothing and personal items should be stored in a separate, secure area. Hair in food can be a source of both microbiological and physical contamination. Nobody wants to find hair in their food. Food workers should be encouraged to keep their hair clean and should wear appropriate hair and/or beard restraints at all times in food processing areas to prevent contamination of the finished products. Hair and beard restraints also discourage workers from touching their hair. Hair can be a source of microorganisms which can contaminate hands and then food or food contact surfaces. Rings, bracelets, necklaces, earrings, watches, and other jewelry can harbor microorganisms that can cause foodborne illness. Jewelry can also fall into food, causing a physical hazard. All unsecured jewelry should be removed prior to entering the processing facility. All hand jewelry that cannot be adequately sanitized should be removed or covered by a clean glove. Employees should not eat food, chew gum, drink beverages, or use tobacco in any area where food or food packaging materials may be exposed or where equipment or utensils are washed. Healthy people frequently harbor pathogens in their mouth and respiratory tract. Pathogens can be transferred to employees' hands and then to the food products that they process when they engage in activities where hand-to-mouth contact occurs. These activities should not occur in food processing areas, and hands should be washed when employees return to work after engaging in these activities. Perspiration may contaminate food, food contact surfaces, hands, and clothing. Wiping a sweaty brow with a cloth or hand introduces potential contamination. Where possible, facilities should be maintained at a comfortable working temperature. Infectious diseases, accompanied by diarrhea or open lesions, are a source of pathogens. Employees diagnosed with Salmonella typhi, Shigella, E. coli 0157H7, or hepatitis A should not perform jobs that require contact with food or food contact surfaces. All of these diseases are easily transferred to foods and are considered severe health hazards. Any employee with symptoms associated with acute gastrointestinal illness, such as vomiting, diarrhea, fever, sore throat with fever, or jaundice, should be restricted from working with food. Company policy should encourage employees to report illnesses to their supervisor so that the employee may be reassigned to a job that does not require contact with food. Exposed areas of arms, wrists, and forearms that contain infected wounds should be completely covered by a dry, tight-fitting, impermeable bandage. Cuts or burns on the food worker's hands should be thoroughly bandaged and covered with a clean glove. The following steps should be used to properly wash hands. Wash hands in hot water, 110 degrees Fahrenheit. Soap should be applied to the hands. The surface of the hands, wrists, and forearms should be rubbed vigorously for at least 20 seconds. The areas in between the fingers, under nails, and forearms should also be scrubbed. Many microorganisms can be removed by friction alone. Soaped and scrubbed hands should be rinsed under clean, warm, running water and then dried with a clean, disposable towel. Except when washing sprouts or when otherwise approved by the regulatory authority, food workers should minimize contacting exposed sprouts with their bare hands. Rather, they should use suitable utensils such as tongs, spatulas, or single-use gloves. Single-use gloves are frequently used to avoid direct hand contact, but gloves may create a false sense of security for food handlers. Dirty gloves, like dirty hands, can contaminate products. Single-use gloves should never be washed. They should always be thrown away when they need to be changed. An employee should put on fresh gloves only after thoroughly washing their hands. Employees should understand the importance of maintaining clean gloves. Single-use gloves should be changed after any activity that may contaminate them. In other words, single-use gloves should be changed as often and for the same reasons as an employee would wash their bare hands. If non-disposable gloves, such as rubber gloves, are used in the facility, they should be washed as frequently as bare hands. Hands should be washed before and after putting on non-disposable gloves. Conveniently located and properly equipped hand-washing facilities are key factors in getting employees to wash their hands. Hand-washing stations should be located in or adjacent to restrooms and should also be located in food processing areas. Hand-washing stations should be clean and well-maintained and should not be used for purposes other than hand-washing. Hand-washing stations should be equipped with hot and cold running water under pressure, a supply of soap, and a means to dry hands. Hot water should be at least 110 degrees Fahrenheit. Cold water does not remove oils, which may harbor microorganisms on the hands. Individual disposable towels are the preferred hand-drying devices. Adequate waste containers should be supplied for used towels. Hand or glove dips may also be considered. Sanitizers designed for this purpose can be obtained from a sanitation supply company and should be prepared according to the label instructions. Hand or glove dips are only appropriate for use with clean hands or gloves. These dips are not a substitute for proper hand washing. The sanitizing solution should be monitored and changed frequently to maintain sanitizer strength. Boot dips are sometimes used to sanitize the bottom of boots or shoes when an employee moves from one part of the facility to another. When properly maintained, boot dips can reduce the spread of microorganisms throughout a facility. However, the sanitizing solution in boot dips can easily become depleted. The sanitizer level should be maintained in the trays in order for these devices to be effective. When used, maintenance of hand, glove, and boot dips should be included as part of the SSOP. Toilet facilities are required for all employees. Employee restrooms should be conveniently located and accessible to employees during all hours of operation. Toilet facilities near work areas promote good personal hygiene, reduce lost productivity, and permit closer supervision of employees. Materials used in the construction of toilet rooms and toilet fixtures should be durable and easily cleanable. The floors, walls, and fixtures in toilet areas should be clean and well maintained. Toilet tissue and disposable paper towels should be supplied, along with easy-to-clean containers for waste materials. Poor sanitation in toilet areas can spread disease. Dirty toilet facilities can also have a negative effect on the attitudes and work habits of the employees. Include these areas in the routine cleaning program to assure they are kept clean and in good repair. Food or food packaging materials should never be stored in restroom areas. Managers play a very important role in helping their employees prevent contamination of food products. Managers should provide a clear understanding of the personal hygiene practices and company policies regarding illness and other health conditions such as infected wounds that could contaminate products. Policies that provide reassurance that employees will not lose their job if they report an illness or a communicable disease should be developed. Management should continually emphasize how important it is for employees to maintain a high level of cleanliness and good health, and should serve as role models for good work habits and acceptable hygienic practices. They should also ensure that visitors are required to follow the same hygienic practices as employees and have policies in place that prevent unauthorized personnel from being in food processing areas. Adequate documented training is essential. Company expectations for proper hygiene and hand-washing procedures should be clearly defined in pre-employment and periodic training programs. New employees should receive training prior to beginning employment, even if it takes considerable time and effort. Once employees understand what is expected of them, effective supervision of employee practices in food processing areas should be used to ensure that employees follow proper procedures. Training should be reviewed whenever incorrect practices are observed. Employees are less likely to follow good personal hygiene expectations when facilities and supplies are insufficient. Management has responsibility for providing properly located and maintained facilities and supplies that will allow employees to adhere to personal hygiene requirements, including dressing or changing rooms that are adequate and properly maintained, laundry services and/or uniform services as necessary, designated employee areas for breaks where eating and drinking is allowed, strategically placed and well-stocked hand-washing facilities throughout the production area. In summary, sprouts, sprout contact surfaces, or sprout packaging materials should be protected from contamination with microorganisms or foreign substances. Achieving this includes having a healthy, clean, and properly trained workforce that understands the importance of proper hand-washing techniques and personal hygiene. Adequate training programs and management supervision are critical to the preparation of safer sprouts.
Sprouts have been scientifically linked to foodborne disease outbreaks, resulting in thousands of illnesses and several deaths in the United States and abroad. Therefore, sprouters should ensure that every possible step has been taken to minimize the chances of producing a contaminated product.
The sprouter should take responsibility for providing a safe product for consumers and for knowing, understanding, and complying fully with food safety laws and regulations in their location.
In this video, we provided the basic food safety concepts that all sprouters should understand in the daily operation of their facility. To recap, we have reviewed good manufacturing practices, GMPs, in manufacturing, packaging, or holding human food that cover all aspects of food processing. Sprouters should review GMPs as found in Title 21 of the CFR Part 110 and consider implementing appropriate practices to ensure that sprouts are not produced in violation of the Federal Food, Drug, and Cosmetic Act.
We also reviewed recommendations in FDA's sprout guidance documents, including good agricultural practices, seed disinfection, and microbial testing. Seeds for sprout production should be grown under good agricultural practices in order to minimize the likelihood of pathogens being present. Seeds that may be used for sprouting should be conditioned, stored, and transported in a manner that minimizes the likelihood that the seeds will be contaminated with pathogens.
One of the most important steps in a grower's food safety program is the routine use of seed disinfection in order to reduce the level of contamination in or on seeds and, in turn, reduce the risk of foodborne illness from consumption of sprouted seed. However, current treatments cannot guarantee total elimination of pathogens. Therefore, FDA is currently recommending microbial testing of spent irrigation water.
Sprouters should employ good sanitation practices to maintain control throughout all stages of sprout production. Facilities and equipment should be maintained in a condition that will protect against contamination. Poor health and hygienic practices by food workers can also increase the risk of food becoming contaminated with pathogens.
As we have demonstrated during this program, there are numerous risk factors associated with the sprout production process, and there's no single fail-safe to prevent the threat of illness. There are, however, techniques and practices, as outlined in this program, which when implemented facility-wide will help ensure the safest possible conditions under which we can deliver sprouts from the seed to the dinner table.
On behalf of the United States Food and Drug Administration and the California Department of Health Services, I hope you found this program to be informative and meaningful.
In the back of the manual accompanying this video, there is a section that includes names, addresses, and phone numbers for state and federal food safety agencies in your area.
You'll also find additional references for food safety resources. Please feel free to refer to them and to refer to this program often as a reminder of how to produce safer sprouts.